Now let's talk about the type 2 error. A significance test makes a type 2 error when it fails to reject a null hypothesis, and the null hypothesis should have been rejected. For example, if we look back at our candy example, where the null hypothesis was that our lowercase p value was 20 hundredths, and our alternative hypothesis was that p is not equal to 20 hundredths. And the sample proportion was 175 thousandths. If the true proportion of red candies was that p is equal to 17 hundredths, we would have made a type 2 error by failing to reject the null hypothesis based on the sample. The probability of making a type 2 error is denoted by the Greek letter beta, and it depends on a few things. It is more common in statistics to calculate the probability of correctly rejecting a null hypothesis than incorrectly failing to reject it, and this is called the power of a test. In other words, it is the probability of detecting a significant difference or effect when one truly exists. The power of a test depends on several factors, including the sample size, the level of significance, and the variability of the data. A higher power means that the test is more likely to reject the null hypothesis, with the majority of the simple random sample, or SRS, that could be chosen from the test. The power of a test is calculated by 1 minus beta, or 1 minus the probability of making the type 2 error. Calculating type 2 errors and power by hand are not easy to do, so we use technology to do the work for us. For the purposes of the AP exam, the questions will provide you with either the probability of making a type 2 error and ask for the power, or vice versa.